Okay, good morning or good afternoon, everybody. My name is Yuding. I'm a professor at the Georgia Tech. We've been doing this turbine performance workspace collaboration since beginning of 2024. This is our 11th meeting. And if you are new here, I see some of the familiar faces, and you know where to find those material from previous monthly meeting. There's a slides, there's a recording. Sometimes the speakers share their method or code or data, and we add a link to that too. But after the meeting, you're going to see an email to me basically to tell you the recording is available. And in that email, there's also a link for you to find where you to find the previous recording, everything. So back in October, Ahmad, who's my PhD student, gave a talk on one of the papers we published about 2 years ago, and it's rather a long paper. That's why we kind of going to continue. He's going to continue this meeting and to finish up discussing that paper. Again, we have a mix of speakers, and I think Peter was one of the speaker early on, and there are other folks speaking about their method and so forth. If you are interested to present your method and in this collaboration workspace, and just drop me a note and we'll schedule you to one of the future meetings. It just so happened all the meeting time has been fixed, right? It's a second Monday of each month and going forward, and it's always at the 10 o'clock US Eastern time. And also, if you have other comments, technical result, data, everything, you are strongly encouraged to do the reply within the WeDoWind workspace. That way, the workspace archived every discussion and all the other things and in a centralized place. I have to tell you, I'm not very skillful in using the workspace. But if you need any help, I think Sarah here is also can help you with some of the things. I believe it's relatively straightforward. You just click on reply and to the original post that we created this particular collaboration effort. So Sarah, anything to add to that?
No, just click on reply. Maybe just to say it, to try to document all the different things that people have done is, I guess, the main point of doing that is to somehow make them comparable and also write a paper eventually. And so we actually have it documented as well as just in the presentations. And then the other thing to say is that I think I said last month as well that we're currently working on a replacement for the digital platform that's actually easy to use and should be announcing that probably in the new year. So look out for that as well. And then it'll be much easier to submit solutions and also to discuss with people on the digital platform. So if you've got any questions, if you're frustrated by anything not working, just write to me immediately and I'll fix it or get somebody to fix it.
Yeah, so far most of the discussion happened within, during the monthly meeting time. There's not really that much discussion outside, right? The email communication is necessary because people don't really know where to find those posts in the first place. So we have to give them link to say you go to this step to find the old recording. Because I receive those kind of email all the time asking me, where do you find the old recording? Some of them join later and was not really in the first session when we said the whole procedure. So that's why we start writing another explanation to say you need to go to this workspace, you need to click on that, and you will find all the old materials. Yeah. Okay, so without further ado, and I will yield the platform to Ahmad, and so Ahmad, whenever you are ready.
Thanks, Professor. Hi, my name is Ahmad Shokhachian. I'm going to talk about the paper published by Latifianti in 2022. The topic of paper is actually exploring the...
Ahmad, I think there's some Zoom problem here. There's block, which I believe is you show this, yeah, you needed to move that a little bit kind of away from your screen. That happened to me previously too, right? I think right now become horizontal, which is fine. Probably block the smallest portion of the screen.
Is it better now?
That is gone. This is good. Yeah.
Okay. Thank you. Yeah, I will talk about Latifianti's paper. It's actually looking for the measurement of leading edge protection applications effect and wind power production. And it has two approaches, energy and power decomposition. So the purpose of this study is to evaluate if the leading edge protection will impact the power production. And there is need for techniques that can separate the effects of weather condition, environmental data, and also the turbine effect. So in the previous meeting on October 14, I talked about the approach 2 in this paper. It is called energy decomposition, and the slides and recording is available on a VidoWind platform. Today, I will focus more on approach 1, power decomposition, but I also have a recap on energy decomposition approach 2. The overview of the problem is like we have two data sets before and after a change or maintenance action, or like a LEP application. The period 1 is X1, Y1, and then the period 2 is the after change period. We want to see how much X and how much the F will affect the Y and will lead in power production increase or decrease. Actually, the authors offered approach 2. Approach 2 tries to decompose the delta E to delta E of weather and turbine. To estimate the delta E of weather, the assumption is like we have an ideal turbine which assume that does not have changes, and then they apply both weather conditions to the power function of that turbine and then subtract. That would be the delta E weather under ideal circumstances, but the fact is that such a turbine does not exist. So what they offered is like doing this on both power functions and then taking the average. That would be a better estimate of delta E weather. The second part, turbine effect, delta energy of the turbine, is almost the same logic, but this time the assumption is that there is an ideal weather condition, which over the time it does not have drastic weather changes or its ideal situation. And then if both power functions are applied on the same X and then subtracted, it will show the delta E of turbine. But the fact is, like, again, such an ideal X does not exist. So that's why, again, authors try to apply this subtraction on both weather conditions and then take the average. By this approach, the delta E of turbine is also estimated well. The approach 1, called delta power quantification in the paper, has 3 steps. We'll focus on this approach more in this meeting, but I have to mention that this work is not originally introduced by Latifianti's work, but it's just summarized and applied to the new data set in that paper. But the origin of this method is in Dr. Ding's 2022 paper, which I provided the citation here. So it has 3 steps. The first step is subset selection. We have a wide variety of the covariates from speed, temperature to the standard deviation of the direction and like turbulence intensity. The first question is like, which covariates should the method use for making a good estimation of the power function? So after making a decision on which one of the covariates to keep, the second step is covariate matching. So covariate matching is trying to pick a subset of data points from two periods that their probability density function matches. We'll take a further look at this step, and then finally, the power curve comparison is to measure the power difference and statistical power difference. So from the step one, the selected covariates are speed, temperature, wind direction, standard deviation of direction, and turbulence intensity. The methodology used for picking these covariates is that they use tenfold cross-validation to find the best subset with the smallest error, MAE and RMSE. So these covariates will be used for the rest of the method. The second step, called covariate matching, is just making the PDF, selecting a subset of data from before and after period such that the PDF looks alike. So here in the plot on the left-hand side is for wind speed. We see the red dashed line with the black solid line has a quite significant difference before matching, but after matching they become same. Same thing is true about the temperature and other covariates. In case I will not go deep to this approach, this step, but in case you want to apply something similar to this on your own data, the function is called co-match in our DSWE R package, and it's relatively easy to use. I will show a document in the next few slides to demonstrate how to use different functions from that package. Finally, last step of this method is like, okay, we have the match data from before and after periods. First, they feed a Gaussian process on each data set, and then uses those Gaussian processes to make predictions on a grid. And by taking the difference of those predictions, the change in the Y or power will become calculated. But the main point of this part is like there is two differences. One difference is just taking the total sum of all differences on the predictions, but the other approach is just taking the differences which are beyond the confidence band. So the second one, which is blue in this plot, blue area is just taking the differences which are significantly statistically significant. So overall, it's expected that the statistical difference is to be smaller than the total difference. About the data, when I talked about the data last meeting, I mentioned that there is 4 periods, all of them around 1 year of the data, and between each of them, each period, there was a LEP application or a maintenance action, sometimes done on all turbines, sometimes on a subset of the turbines. But in today's presentation, for some of the tables, another period of the data is used called period 0. It's just 1 year before the period 1. And that's used in the analysis to see if without any LEP change, there is, what's the order of the change from period 0 to 1. So overall, there's 7 years of data, and they are just 5 periods from period 0 to period 4 on 5 turbines. In case you were interested to download this dataset and use it for your own methodologies, you can visit Dr. Yuding's personal website and click on data science for wind energy. Then the book is available also for is open access to download. But the second bullet point on that page is datasets. In the datasets web page, if you scroll down it until seeing the extension datasets, the first one actually has the citation to the to the paper and also to the datasets code and reproduction report. Both dataset and code are uploaded onto on Zenodo platform. So the data is just divided to 3 parts each for each turbine, because it's like 7 years of data. It will be a big file if they just use one CSV file for each turbine. So they cut it into 3 parts, but it's easy to just merge them and use for the analysis. Like in R, the syntax for this is rbind. I have also the citation on this slide, so I think Dr. Ting will upload these slides and recording to Vidwin, so you can access also from these links on my slides and access the data and code. And we also talked about the code. You can download the whole code for all plots and figures in the paper, but then you gonna extract it, but keep in mind to set the path to the correct folders after for reproducing any of these tables or figures. But the big question is still how to implement the approach one. It's already coded and available in our package, so there's no need to code it yourself. It's just using the functions in DSWE package. To load it, you can just run install that packages DSWE in parentheses in R, or use the package tab in the R to load the package. This is available on CRAN, so it will be easy and smooth to load this package. Then we have a help document on our GitHub page, and it's also uploaded on Zenodo. You can click on it and download the tutorial. In the help document, we have all the functions, and also there's small demo examples and use cases of each function. For example, compare p-curve is the function for implementing approach one. There is just a few lines of code needed to run it. So the first step is just get the data sets from the CSV files and then create a list of that data, specify the columns of the data, like the power output and input columns, also the columns that needs to be used for matching. And then compare p-curve function will run the model and give out the statistics for a variety of statistics for measuring the power change. The main table for approach one, table 3, is produced with this structure. So it has period 2 as the base period and compares all other periods with period 2. Also, in case you wanted to run code to generate this table, is 01 table 3.r. This is the table which I discussed right now. Table 3 shows the approach 1's results for comparing the power production for any turbine between different periods. So I actually have 2 examples on the table. One is period 1 for turbine 5. The number over there is 1.53%, 53%. That means on period 1 for turbine 5, on period 1 makes 1.53% more power compared to period 2. And then so all these numbers are compared to period 2, but in case just we want to get the comparison over periods 3 and 1, it's just easy to subtract them. 1.55 minus 1.53 53, then the period 2 will be canceled out, and the remaining will be the amount that period 3 has extra production over period 1. So what the other question is how robust this approach is. And to get the answer, the authors compared it with industry standard method binning over 5 turbines, and results shows good consistency over all turbines. The data used here is 12 months of data on period 3 and period 4. So it somehow tries to measure the power change from period before and after second LEP change. Next is to measure. So in the previous slide it was 12 months, but the authors checked the sensitivity of the method to different lengths of the data. So one time they picked 1 month before and after second LEP change. The next time they picked 2 months, 3 months, and then created the 1 to 12 months of the data. And run both, they implemented both binning and approach 1, and this on one specific turbine number 2. And the results showed that when the data amount is sufficient, like more than 6 months, the results from approach 1 seems more robust. But when it's the data is less than 5 months, then after the matching, remember matching was taking a subset of data to match the PDF functions. So when data length is small, after matching, there's not enough data points remaining for approach 1. That's why it's not suggested to use this method for less than 5 months of the data. On the other hand, binning is not really sensitive to the data size, but binning does not have a control on weather conditions, so it can be affected by drastic weather changes. So then we are getting back to the approach 2, which we showed in last meeting. We want to see how these two methods, approach 1 and approach 2, perform compared to each other. So approach 2 was able to measure both the energy change due to weather and due to turbine. But approach 1 is getting the power difference because of the turbine change. So by comparing two last rows of this table, we see consistency over here too. So it's not expected that they have matching numbers because the methodology is different between these two approaches, but the consistency is expected. Then the other thing we discussed was T2P and P2T. So it's like a sanity check to see if the methods work fine. So one can apply these methods on two different periods of one turbine, and then do the same thing for another turbine, and then take the subtraction. So that will show what's the performance change from turbine to turbine over 2 periods. The other approach might be taking just one period and taking the comparison over 2 turbines. And then again doing that for the other period and then taking the subtraction. So delta energy of P2T and T2P is also expected to be the close. Like in this table, the first block is T2P based on approach 1. Approach 1 takes like one data set, data 1 as the turbine 1's P3 data, period 3 data, and then takes the turbine 2's P3 period 3 data, and then just feeds it to the compare P curve function. Then it will give the number we see over there. The same thing can happen for period 4 data, and then by making the subtraction for T1, T2, the difference is 3.43%. The other criterion T2P also gives the same number for T1, T2, which is 3.43. That's not matching. In this case, both methods are matching, both directions actually. But for the other turbine by turbine comparisons, they do not match exactly, but they are consistent with each other. On the other hand, for P2T, we also see that there is overall consistency between approach 1 and approach 2. And also for both criterion, P2T and T2P, remember they don't need to be exactly same, because like for matching the data for approach 1, if we are doing the other direction, actually we are matching two different data sets. So they are not expected to be exactly the same, but we see the consistency over here. To summarize my slides, the power decomposition approach 1, does first match the environmental conditions and then measures the power change over those matched data sets. On the other hand, energy decomposition splits the total energy change to between the weather effect and turbine effect. Power and energy decompositions are consistent, and for less than 5 months of the data, approach 1 power decomposition is sensitive to has sensitivity because of losing the data in the matching step. And we also saw the binning approach. Binning approaches may be good as for large data sets, but it still is not controlling on the weather condition, environmental condition. That's all. Thank you for your attention.
Okay, thank you, Hamad. And we have, about 30 minutes left. I know, Christian, you said you probably have to join other meeting, but feel free to go ahead. For those folks are able to stay, any questions, any discussion or comments? Okay, no questions? Well, that's great. Typically, we always have some of the questions and discussions after the presentation. Anyone interested in give a talk, share your own research, point out to a different data set and so forth in the December meeting or not? The December meeting is going to be December 9th, I believe. December 9th, 10 o'clock Eastern Time, United States. So if you cannot decide right now, please drop me a note afterwards. We do have roughly about a month to decide. I do want to know a little bit kind of ahead of time to put on the schedule. And if I don't really receive any feedback from you before the December meeting, I think Hamad probably going to present some of the things we've been kind of trying. If you recall in one of the early meetings, some of the folks have been here long enough, we talk about there's two problems. One is, when the wind speed, because it's measured on nacelle anemometer, which is in the wake, that is the imperfect measurement, right? Because for the power curve function, you would ideally like to have the free stream measurement. How could we possibly can use some of the data collected in the field and use some kind of reverse engineering to get a better estimate of the free stream equivalent of those things, right? So we did a little bit kind of work and I'd like to share with the group and to see, how that can be further improved. And if there's no other volunteers for speaking for the December meeting, and I think that is the current plan, right? But that can wait, right? If you have something in mind that you like to share, we can schedule you for the December meeting. And like Ahmad said, all this, the paper, the method, and the data, which the Wind Energy Institute of Canada very generously shared, used in the paper, and they agreed to release the entire set of data to the general public, right? It's close to 7 years of data. I believe it's almost 300 megabytes of the data. So it's quite a lot of data, and you are more than welcome to download and give a try and to see how that works, either the method already being published and reported, or on your own method, right, as a benchmark, or some of the method being discussed during the course of this particular collaboration effort. Anything from the audience? Comments, feedback, suggestions?
Hi. On my side, no, thank you. No suggestion, but just to say that I find the presentation very useful. So thank you, Ahmed, for presenting it.
Thank you so much.
Yes, from my side, thank you, Ahmad, for the presentation. It was really nice and really useful. Like, now I think I should read through the paper, and then maybe I'll have a better understanding of the methods described. Yes. And about the method that you suggested, that you were discussing, about not using the nacelle anemometer wind speed. That is, I think that is something that we'd be really interested in here at PowerCurve, because many times we work with blade upgrades, in the sense there are add-ons or other upgrades done to the blade, which in our experience suggests that the upgrades themselves will affect the anemometer readings. So there I think there are interesting methods that data science can bring in.
Right. The current research Hamad just presented still use the nacelle anemometer measurement, right? But we understand that actually in the first 2 meetings of this year, like February, March meetings, that was quite a heated debate about what else you can use. There's not really that many options. The technology-wise, there are alternatives, right? The LiDAR you can put over there, but on the daily, regularly operations, and the people still don't really get the point to put the LiDAR in front of the turbine all the time, right? There's a newer sensors. I believe there's a German company actually made a sensor measure the free stream instead of in the wake. They actually can get a sensor outside the cap of that rotor part. I first heard about that sensor 5 years ago in 2019, one of the workshop in Houston. Up to this point, they're still not being massively adopted. My understanding is because of the price difference, right? I don't know how much that one is cost, probably like $3,000. So the anemometer is probably a whole lot cheaper. So
Yes.
that's probably the reason they're not being broadly used. And so there's still plenty of turbines still use the sensor being measured in an anemometer. So we want to, if we get, we don't have any other speakers volunteer, and Ahmad can present some of the things, and as one of the first step. It's a relatively simple ideas. Other people suggest similar ideas. We just carry it out and want to use that as strawman version and to elicit any more kind of discussions from the expert in the panel.
Yes. Right now we're trying to use this. Mostly use a side-by-side method where we compare one reference turbine for power reference, and then compare the performance in the before and after periods. But about Nessel anemometers also, some methods suggest the use of the Nessel anemometer readings from a reference turbine instead of the upgrade turbine, because of the reasons that you suggested. Any blade upgrade can potentially affect the Nessel anemometer. For example, you put on a vortex generator or a gurney flap, it's going to affect the flow to the Nessel anemometer. It's going to create an offset. So yeah, like you suggested, the methods range from simple use of neighboring Nessel to using advanced equipments. Yeah, I would be interested to see where the discussions go to.
Right. So the side-by-side comparison, that idea probably is one of the very first, right? The 15 years ago has been, and people use that in somewhat different ways. And in the early part of the year, actually has also been discussed and mentioned in a number of this kind of presentation. So I strongly encourage you to take a look of the slides we already posted on the workspace. And I would like to invite you, if you are willing and available, to kind of share your way of how you're going to do this kind of side by side. I think the general idea is very similar, but there's a detailed differences between each different group, different company, how they going to use that, right? The problem is still even two turbines is pretty close with each other. And the people assume the wind profile and it's going to be identical, but they are not exactly identical. And that small difference sometimes. What you mentioned about the modifier of the blade affected the transfer function. That's very true, right? Sometimes can change wind speed between 0.5 meters per second to 1 meters per second. If that happened in the region 2, that's a big deal, right? That really kind of make a very large difference in estimation. We worked with EDP in North America and also Smart Blade Germany, and published the joint study. I mean, we published the joint study with Smart Blade, not with the EDP, back in 2015 for the VG installation, right? Because the Smart Blade was pretty much specialized on doing that. And then subsequently some other things. The LEP protection application also have impact on the airfoil of the blade, not as much as the VG installation, right? But nevertheless, is one of the issues people are concerned with. Yeah.
Yes, thanks for the invitation. I'll confirm soon if I can present
Okay.
for the coming meetings. Yeah,
That'd be great. Okay. Well, if there's no other comments and suggestions, we can end the meeting earlier. Because for every meeting, my intention is really kind of have a presentation roughly about 30 minutes and 35 minutes. That leave plenty of time for discussion and so forth, right? And if we can finish the meeting by 15 minutes, that would be great, because that leave a little bit time for folks to grab a cup of coffee, go to bathroom break before go to the next meeting. And but today we went earlier and we are at the 40 minutes mark. But that's okay, more time back to individuals is great. Okay, so I will post the recording and the slides after the meeting, and you will see email from me and telling me when they are ready. Okay, and you have a good evening or good day, and depends on where you are. Okay, I'll see you in December.
Thank you.
Yeah.
Thank you. Bye.
Bye.